Hi, I'm Ryan Nickel, CTO at DSA, and right now I want to show you how to make a custom bathymetry mesh in Rhino to use with a ProteusDS simulation. What we're going to do is make this custom mesh from a set of bathymetry data points. There's many different ways of getting these data points from many different sources, but generally speaking, they're vertex information in some kind of format, usually in a text file that might look like something like I've got in my sample file here. So let's get started. We'll open up Rhino. We'll be using large objects and meters. We start off by importing the bathymetry data points file. It'll ask you for a delimiter, but it does a pretty good job of automatically detecting what you've got. So there are all our data points. Now in this case, this is already in terms of a ProteusDS coordinate frame, so we don't need to make any changes to it. So the first thing we're going to do is make sure we've selected all the points and call this patch command. So now we've got a surface patch. This isn't the Polygon Mesh. We're going to make a Polygon Mesh from this geometry. But before we do that, we're going to make a quick trim so we don't have too much extra information in here. We're going to make a line that surrounds the data points here and then use that line to trim the surface mesh. So we use the polyline command, P-O-L-I-N-E, polyline. Sometimes it helps to have OSNAP on end or near and point. And we don't have to be super exact with this, but you can see that we're kind of clicking on points to just roughly get the outline here. And we don't have to be super exact because usually the system you're looking at will be will be far from the boundaries of the bathymetry that you've got. So I'm even just going to cut across here for simplicity. There we go. Okay, now we want to trim off this excess surface geometry of the seabed. So we're going to click on the polyline and we'll type trim. And we got the polygon selected, so if we click on the surface there, the surface is now trimmed. And we're just going to hit enter to finish the trimming operation. So now what we have is our surface. We still have the data points, and we have our polyline. And what we're going to do, the only thing we really want right now is the surface. So I've selected everything. I'm going to hold down Control and then left click to exclude the surface from that. Then delete. I just don't want to get things too messy for when we're preparing to export the mesh file that we're going to generate in a moment. So the data points have helped us make this surface. We don't need them anymore. That's why we've deleted them. Now we make a polygon mesh from the surface that we've got here. So we'll just click on that surface and press enter. Now there's a couple of ways of doing this. You can preview and just kind of see roughly what you get. Triangles don't matter too much if you're using them with Proteus for the seabed contact algorithm. So this kind of looks fine. If you feel a bit nervous how big some of the polygons are, you can make some refinements. And that's pretty much all we need to do for our mesh. We don't want to export the surface. So what I want to do is you can use the select tool to fine-tune what you're selecting, but I'm going to select the surface there. I've got the surface. Delete. Now the only thing left is the polygon mesh. This is the only thing that we need to export and the only thing we want to include. The last thing we need to make sure of is that the normals of the polygon mesh are pointing in the right direction. Now by convention, we need the polygon normals to be pointing up from the seabed towards the water surface, and that's the opposite orientation for the Rhino coordinate frame here. So the Proteus coordinate frame is at the sea surface, the water surface, positive Z pointing down towards the seabed. So what we'll do is we'll highlight the surface and we type in dir for direction. Oops, it looks like the normals are the wrong way, so we have to flip them. Type F for flip, and then press enter when done. So we're all done. And now we can export that selected mesh. I'm going to call this, and we export it to OBJ format. We call it bathymetry points cloud.obj, and we go save. There'll be a few options here. Generally, we're going to leave them as default here. We don't want map Rhino Z to OBJY. Uncheck that one. And then I don't believe any other settings need to be changed, so we'll go OK. Now we've got our bathymetry points cloud OBJ file. You want to see what that looks like in a Proteus simulation. Just make a new folder here. We changed custom bathymetry to on, and then right click, resolve follower properties, and it's going to ask us for the OBJ file to use. Bathymetry points cloud. I've actually got to copy this into the simulation folder here. So we'll just make a real quick run. And you can see that it's a little hard to see, but you can see we've got a pretty shallow bathymetry there. If we turn off the water surface, you can see the bathymetry. And of course, don't forget we have some bathymetry plotting to show the depth of the points there. So that's one way to get a custom bathymetry in your simulation using a points cloud. Thanks for watching.